So, welcome everyone. Today we'll be discussing about the next evolution in software delivery, which is basically moving our CI/CD pipelines from simple autonomy to actually true autonomy. Um, Today, we'll explore about how to wire intelligent agentic workflows into the development cycle to create processes that are not just faster but also fundamentally smoother and more intelligent, which will eliminate the daily frictions that we have all come to accept as normal in our CI/CD development. So let's quickly talk about the paradox with CI/CD. It is no longer a novel concept. We have been using CI/CD for years and years now, and it is actually a bedrock of modern DevOps and high performance engineering teams. And it undeniably has accelerated software delivery, reduced downtime, and also improved the quality of products through automation. And we have built these incredible pipelines that automatically build, test, and also deploy our code. However, there is a paradox here. Despite the high degree of automation, the day-to-day experience for developers is often far from frictionless. So we have successfully automated most of the discrete steps of the processes, which is like building, testing, the execution, deployment, and things like that. But we haven't actually automated the intelligence aspect of it, the decision making part of it, and the cognitive workload that actually connects these steps. And this gap creates a constant stream of minor but cumulative frustrations, which I called deaths by a thousand paper cuts, which drains the productivity and the morale of engineers. So let us define what are these paper cuts, because the title of my talk is about paper cuts in these. So these are basically small, persistent points of friction that we all encounter daily as engineers and developers. Um, first and foremost is slow and subjective reviews. You might have heard of situations where a pull request can sit for hours or days waiting for some human reviewer. But when the review does happen, the feedback can be inconsistent, which it's actually there's a name for this, which is called reviewer roulette, where the quality and focus of the review depends entirely on who the review is assigned, rather than um, how the code is written. Right. The second is the security bottlenecks. So we have done a great job in actually integrating security tools like um, static application security testing, or as we call it, SAST, and software composition analysis, or SCA, in our pipelines. But while doing so, we have often just shifted the problem. So instead of knowing these unknown vulnerabilities, we now just face a backlog of alerts, creating a new issue for us, and then turning developers into full-time vulnerability patchers. So this creates an alert fatigue and slows down feature development. Then the third is complex debugging. So when a pipeline fails, it's not a simple fix in many times, and identifying the root cause becomes a separate issue by itself. And is it the issue in some new code that we did, or is it a test that's flaky, or a misconfigured environment, or maybe an outdated dependency, right? So this ambiguity again adds more to our time. And fourth is inefficient testing, which is when we write code, we often have pipelines that take a brute force approach, where we run an entire regression test suite for just a small minor change. So like just a one line edit, it shouldn't trigger hours and hours of testing, yet it often does, which is a massive waste of computational resources and, most importantly, developer time, right? And to combine this all culminates into a cognitive overload. Developers are forced to constantly switch context, from writing code to chasing down PR reviews to deciphering a failed build, to triaging a security alert. And this constant switching is a well known productivity killer and a major source of developer burnout. And this is something that we're trying to tackle with this new agentic CI/CD development. So what is the path forward here? We basically require a paradigm shift. So we must move beyond simple automation and we must embrace autonomy. And I think my thesis here is that we can eliminate these paper cuts by adding these intelligent AI agents directly in our CI/CD workflow.
Yeah, I mean, there's some great talks here, but what I'm really looking forward to, and I've been to a couple of these GitNation shows, panel talks, when you're with a whole bunch of other people, you're getting these great conversations going on. That's really fun.
So the goal here is not just to build a pipeline that is a sequence of automated steps, but also a pipeline that is proactive, adaptive, and oftentimes also self-healing. A self-healing system is basically a system that anticipates problems, makes intelligent decisions, and actively works to resolve the issues without human intervention. So over the next like 15-20 minutes, we'll also talk about how to achieve this. We will start by defining the agentic paradigm, and then we'll walk through the anatomy of the agent powered pipeline. Um, so what is an agentic workflow? Let us first establish a clear definition. An agentic workflow refers to an AI-driven system that can operate autonomously, adapt to changing conditions, and intelligently execute tasks without requiring constant human oversight. So this is different from our traditional automation, like robotic process automation, or as we call it, RPA, which follows a rigid predefined set of rules. The core components of an AI agent give this advanced capability, which obviously has the LLM to understand complex situations, a planning module to break down goals into steps, and the ability to use tools like calling APIs or running scripts. And of course, we have the memory to maintain the context of everything that's going on. And the key differentiator here is the shift from reactive rule-based system to a proactive and adaptive system. Um, so this shift is not merely an incremental improvement, but it actually represents a fundamental change where the decisions are made. Um, Traditional automations are usually pre-programmed decisions made by humans, but in case of these agentic systems, they are capable to make their own decisions in real time to achieve a human-defined goal. So, with that, I'd like to introduce CACD, or rather, we'll call it continuous agentic and continuous deployment. Um, so we are moving on from CI/CD to CACD now. Um, this is just not like sprinkling a few AI powered tools in our existing YAML files. It's actually a deeper architectural change. So we are moving from a rigid linear pipeline that resembles an assembly line. Imagine like CI/CD is an assembly line, to a dynamic collaborative system that has a high performance pit crew like in Formula One. Um, so an assembly line is of course like a predefined sequence of tasks. If one station fails, the entire line stops, and you have to have a human to intervene and resume the process. But on the other hand, a pit crew is a team of specialists with a shared goal. They communicate and adapt in real time to whatever the situation demands, which is the mental model for an agentic pipeline, a dynamic, self optimizing system where intelligent agents collaborate to get code into production more safely and quickly. So this is our new pipeline team, which is our, I call it the AI pit crew. So we have all of these agents in here. We have the code reviewer agent, the security analyst agent, the test strategist agent, the release coordinator, and the orchestrator agent. So these agents probably don't need any explanation. They do as what their name suggests. Um, and all of these operate collaboratively in a single in a cohesive way to achieve this fully autonomous CI/CD workflow. So this is the evolution of these workflows, I'd say. This is a traditional CI/CD with AI tools, and then finally CI/CD as we define right now. Um, we have these traditional rule-based decision making in a YAML file in a regular flow, and we have reactive feedback, which provides us with like build status failures and things like that. The middle column is what we are using right now. We have tools like GitHub Copilot, which provides suggestions, but you still have to have a human that must interpret the output and make the final decision. And this is still largely linear because the developer acts as a collaborator along with the AI. But we are thinking beyond that, which is our agentic CI/CD or CI/CD workflow, which is the final part where we want to reach, where decision making is autonomous and delegated to agents, and the feedback loop is more proactive, with agents not just suggesting but also acting on the changes, like auto refactoring code and security moving from simple alerting to automatic remediation. So this is what I'm talking about, the evolution here. um, and then we also have the final orchestrator, which, is, as the name suggests, is an orchestrator that uh, overlooks all of these agents and makes sure that the final delivery is as expected. So this is the anatomy of an agentic pipeline. This is how the journey of a pull request would look like. So this is how, like, we're going to like follow each and every step here. We're going to follow the journey of this pull request through this pipeline and see how our AI pit crew collaborates at each stage, using real world tools that exist. So we have these four stages that I've defined. Now let's see the first stage, which is the AI pair programmer or code review. And you might have used a lot of these tools. One of them is GitHub Copilot Code Review. And so the moment a developer opens a pull request, the first agent gets to work, which is the code reviewer agent. It is embodied by tools like Copilot Code Review, and it immediately begins its analysis. It it directly addresses the slow subjective review paper cut, where you don't have to wait for an engineer to review your code. You just have this reviewer that is starts immediately as soon as you open up a request. And it's not just a linter, it does check a lot of deeper things that a human would, because it is an LLM powered reviewer and can understand the intent of the code. It can check for logical flaws, performance issues, or violations of complex term specific architectural patterns that are defined in the code. So for example, you can like create a custom instruction in your repository that says that the auth server should never make a direct database call. It was always go through the user management service API, and the LLM would actually understand that, and it will see that if you're making similar changes or like making any direct calls to the database API, and it'll give you actionable feedback. Um, it's not going to be just like cryptic warnings, but it will actually trigger and give you comments, and also give you and like also potentially give you like a first pass where it'll like maybe fix that problem for you also. And um and basically, yeah, that is the first stage. The second stage is using autonomous security analysis, which is through tools like Semgrep Assistant. um, this complements tools like CodeQL, which also provides its own AI generated fixes. But it also introduces two more advanced agentic capabilities. Firstly, it is intelligent triaging. It uses an AI model to actually analyze findings and predict which one of them are going to be false positives, and automatically filtering them out based on the developer's view. And this directly attacks the paper cut that we are talking about, which is alert fatigue and noise, ensuring that developers actually spend time on real issues. And second, which is perhaps the most impressive feature, which is it features organizational learning through a feature which it has, which is called memories. So when a developer triages a finding or customizes a suggested fix, they can provide feedback to the agent, and the agent remembers this preference and applies it for future suggestions. So, for example, if your organization prefers a specific internal library for sanitizing inputs rather than something else, the agent you can let the agent know that this is a preference, and it will incorporate that into the knowledge and into its remediation advice going forward, which is a key characteristic of an advanced agent, right? Which is the ability to learn and adapt based on feedback from the environment. Um, Now, the stage three, which is the intelligent test strategist, where once the code has been reviewed and it is now secured, there are no security flaws, which it moves to the third stage, which is the testing stage, which um, the agent tries to solve this inefficient testing paper cut. So instead of running every test in the suite, the agent uses predictive test selection. The agent will analyze the changes in the code that were created, and it will understand the dependency graph of the code base and consult on historical test runs. And based on this context, it will select and prioritize the most relevant subset of tests that are most likely to catch a regression from the specific change. So basically, like, to give you an example, a gaming firm actually implemented an agent that intelligently skips unnecessary tests after a small UI tweak, and this actually helped them reduce their overall testing time by 30% without any loss in effective test coverage. So this agent acts as a critical resource optimizer, which saves valuable compute time and also shrinks the feedback loop for the developers. So all of these tools are specialized agents, but their true potential is only realized when they are orchestrated as a cohesive team, which brings us to our final stage, which is these orchestrating, like building the team through an orchestrator agent. So these individual agents are powerful, but they don't collaborate together. So we chain their actions through an agent orchestration framework, which is, you can call it as a central nervous system of this whole setup. And there are multiple tools for that. So, for example, this is LangGraph, which is open source, and there's also another one which is AutoGen by Microsoft. Um, so LangGraph actually uses like a graph based approach where it has a sequence of conditional flows and a conditional edge, which basically checks for outputs of the agents. Like, for example, if it'll start with the code review agent, it'll check the output. If it found critical issues, it'll go to the next one, and basically it acts as a flow. It acts in a singular flow, and if all the checks pass eventually, then the workflow moves to a final human approval node where the entire process pauses. It posts a summary for the human and waits for the maintainer to give the final go signal, and only after that the graph is proceeded to the end state where it will trigger the merge. This is a approach which basically provides the control and reliability needed for production systems, directly addressing the trust and safety concerns which are inherent in autonomous system, which is basically the final human approval node. Um, a different way to look at this is the AutoGen framework. So while LangGraph uses a structured flowchart, AutoGen is more like a dynamic conversation where you define a set of agents with different roles and they collaborate by actually talking to each other, where, like, imagine like a managed group chat. The flow of conversation is not rigidly predefined as it was before. It emerges based on the dialogue between the agents. So this approach excels in complex open-ended problems that require creative brainstorming or multi-step diagnosis. So basically, you have all of these agents that if one pops up an issue, then it will communicate that to the others, and things are dynamic. It's not like a fixed flow as we saw before. That, hey, if this condition happens, then go to the next agent and things like that. These all agents are working together and proposing solutions until the root cause is found out, as you can see in the in the flow chart here. So with that, we have actually built a highly autonomous CI/CD pipeline, but it it naturally raises the question of trust. The traditional merge gates, which is test coverage and thresholds, lint checks, vulnerability scans. These are vital, but these are primitive. They treat every change as the same, reducing complex judgment into binary yes or no. So this result is both inefficient and has risks of low impact changes. Low impact changes can get blocked by unrelated noise, while critical changes can pass without sufficient scrutiny. So with that, we introduce like a final quality gatekeeper, which is an intelligent agent that acts as the final arbiter of merge readiness. So it aggregates all of these signals across the entire pipeline, which is like code complexity, test coverage, deltas, security fix confidence, review sentiments, performance impacts, things like that. And the agent doesn't just give you an answer whether it's a pass or fail. It gives you a merge confidence score, which is like a number, and it'll give you an explanation that low complexity, high test coverage, one remediated medium vulnerability with like no performance regressions. And then this scores drives the human in loop strategy. High confidence merges can proceed automatically. Ambiguous ones surface to humans for approval, and the risky ones are blocked with detailed reports. And this creates a trustable system that scales with human judgments, and it keeps engineers focused where they are more needed and elevates merge gates from static rules to dynamic intelligent assets. So let's quickly recap our journey. We started by identifying these paper cuts, and then we saw how an agentic approach can heal these cuts by providing instant intelligent reviews, um, providing automatic remediation of security problems, and implementing efficient and adaptive test strategies. Then we saw our AI pit crew, which were these specialized agents, and then we also learned how to organize these agents using an orchestration framework like LangGraph and AutoGen. And finally, we designed an intelligent AI-powered gatekeeper to ensure that this pipeline remains safe, trustworthy, trustworthy, and also under human oversight. Which is a The final result here is a development process that feels like uh, less like a series of frustrating hurdles, or I'd say paper cuts, and more of like a state of superfluidity. So this is a technological shift, and which will inevitably transform our roles as developers. And the good news is that while it automates the most of the tedious, frustrating parts, and we'll spend less time fixing these vulnerabilities, deciphering build logs, or waiting for reviews, and which actually frees us up to focus on things that actually matter, which is high-level system design, tackling novel architectural challenges, and deeply understanding the business problems that we are trying to solve. And of course, with this, the developer's role is going to evolve from we'll be moving from primary coders to becoming designers and orchestrators of intelligent AI systems. And I believe that the most invaluable engineering skill in this paradigm will be the ability to design, guide, and oversee the agentic systems. And as one expert might say, prompting is the new debugging, and it is not about replacement, but it is about elevation of roles as a developer. So, what is the long term vision here? So, the next horizon is a pipeline that is just not populated by agents itself, but is an agent itself. So, imagine a system that can monitor its own performance metrics, lead time for changes, change failure rate, mean time to recovery, and use all of this data to reconfigure its own workflows. So it might learn that certain class of changes rarely benefit from like a full security scan and and it will dynamically adjust its own rules. It will be able to experiment with different strategies to find the optimal balance of speed and coverage. And basically, this will achieve the ultimate goal of pipeline becoming adaptive and a self-learning entity that is also a self-healing entity, which is the ultimate goal of agentic CI/CD, which is essentially a development ecosystem that will autonomously and continuously improve its own efficiency, reliability, quality, and allowing human engineers to focus on entirely new things and a new set of skill sets. And with that, I'd like to conclude the presentation. These are some of the links where you can reach me out, and you can also get the slides at the link mentioned below. So thank you.
Thank you, Chaitanya, for your session, and we are ready for some questions for you. How you doing today?
Doing great. How about you?
Awesome, awesome. Good to have you here. I'm pretty good, and excited for how AI Coding Summit is going. And let's start now with question number one. How will you integrate CI/CD in your team company? By using N8N workflows, Cursor CLI rule checker, or etc. Which is the best path forward from your experience?
Yeah, so I think I like referenced this in the slides. You can use like an agentic framework. Usually, I think LangChain will do a pretty good job. But if you're like not too like uh, heavy on coding, maybe you can like N8N is also pretty nice. Yeah, I mean it basically all boils down to like which tool you like, because all of these are pretty much capable of doing these jobs. I have had good experiences with LangChain because it's pretty customizable and flexible. And I mean, like even if you don't know anything about it, you can always like use AI to write this for you. So yeah, that's that. Like essentially, like whatever tools that you are using in your teams or companies, like usually you have like an authorized list. Anything should work. You just like follow these set of um, like structure your whole workflow into these agents, and you should be good to go.
Wonderful, wonderful. There is another question here. Are we pushing the paper cuts down the line, like shifting right? The orchestrator manages the three agents, but there is still a human validation at the end. Now that human needs to review what was done in all the three steps. This doesn't need like there's a large paper cut.
Yeah, that's actually a good question. The reason that it's not a large paper cut is basically we are pushing everything into like firstly like we are automating all of these steps that firstly a human would do. So that is removing the friction between humans doing all of these steps. And of course like there will be a final approval stage where like you just do some form of validation, but I don't think that will be like a large paper cut, because like as you mentioned, like you're right about like reviewing all of the three large steps. But here the inherent assumption is that the AI is 99% right, and you're just like looking at the 1% that it might go wrong. Like if we make the assumption that the AI is wrong like 50% of the time, then of course it's going to be a bigger paper cut. Um, but like here we assume that the AI models are getting pretty good, and like we basically just need to look at the last step. And like humans who are like experienced in this, that's what they're good at. Like you can look at something that is already done. Like for example, if you're like evaluating someone else's code, you can just like glance at it. You can just like at a high level you can start picking out comments and like things that you could might notice just by like skimming the code. That's pretty much what you're doing. Like you assume that this is somebody else doing the work, and it will like look like a very small validation step that you do instead of like a large paper cut. um,
Well, thank you so much. Another question here. I have often seen that Copilot review lacks the context of product requirements and it is not able to pinpoint a particular use case not being covered. How do you manage or how do you achieve this?
So yeah, I think this is a challenge that a lot of people are facing right now, and the biggest cause for that is the context window. The context window is not like super super massive for these models. Like you basically like now that we're getting pretty good, like for example, Gemini, they introduced like a 2 million token context window. So the more the context window we have, the more information you can feed to the LLM, right? And of course, like there are some things that like Anthropic is working on. Like for example, Anthropic recently added this feature called skills, or you can like also add like for example preset of instructions where like for example if you want to let's say if you're like writing a web app and you have a front end and a back end, you basically segregate the app into two, like the front end and the back end, and you have individual agents work on each of these steps. And basically that's how you like segregate it until this problem of context is solved. But as soon as we get there, this shouldn't be a problem. Like like if we move to 5 million or like 6 million context window, it is pretty much enough for like massive code bases. So and I'm pretty sure that will be coming soon.
Good, thank you. We have another question here. This topic is pretty spicy now. So, how do you make sure that Copilot Review considers the impacted code too, like dependencies? For example, while reviewing the code of one micro frontend, how the change is going to impact another micro frontend that it's consuming it.
Yeah, so in this case, like for example, if you have are you like I guess I'm assuming you're talking about like when you like like talk about
You
like
have like
impacted
two
code.
different components that depend on each other, or one change is going to impact the other one. Who are going to make sure that the
Yeah.
review that we are doing takes into account that there is no conflict or there is no impact on the other component or micro frontend in this specific example.
Right. Yeah. So basically, when I mentioned in the whole CA/CD workflow, the idea is we always have like a test strategist, which basically is responsible for writing the test suite, right? So this is like we don't have an AI agent that basically considers secondary impact. Like it just fixed the part, and then there'll be the test agent that will write the tests and basically run the tests and see if the integration tests are passing or not. That's like it's similar to what humans do. Like we don't have to worry about that right now. Like that's why we have these regression tests, right? Because if there are so many people working on massive code bases, you are only working on your part. You don't know what's going on in the other code base. So you write your code, you write a test, and you see if the test fails or passes, right? That's exactly how this is. And this is meant to like mimic human behavior. And
Yeah.
if you don't even have like a massive code base, again, like everything can just fit in one context window. You can just literally throw the whole code at the LLM. If it's not like a very massive code base, it should be able to. Like to give you some context, like I think in like a 3 million context, probably you can fit like the whole Linux kernel source code. So, and that's like a very massive source code. Assuming like you're working in the limits of that, you should be fine. And again, like you always like right. That's why you have these tests that make sure that um, integrated components are working together.
Yes, definitely. This is not replacing like the regular like software like cycle techniques that we know. So yes, we need to have like proper tests for this. There is another. I think this is a pretty similar question to one we already asked. Is how can we ensure that Copilot Review understands the context, like our coding guidelines, such as requiring every component to have both test and a story, etc. So how can we make sure that Copilot understands these by default?
Yeah.
Because it seems it
Um,
doesn't do it.
yeah. This is like pretty similar. Like if you have used Cursor or like all of these tools, they have added like these files. Like for example, Cursor has one called Cursor Rules. Or if you're using Anthropic's tool, it has an agents.md, or like even I think Codex also supports that. That's where you like write all of these guidelines where like which frameworks to use, or like what are some of the things you expect the model to write, and basically what it does, it just like reads the file and it puts it in its system prompt. So there's like a big repository of like coding guidelines for like a lot of frameworks, like which components to use and things like that. You can just like maybe just search for like cursor rules GitHub, and you can like find the repo. There should be like a ton of examples about how people write these, and then you can obviously customize based on that.
Awesome. And last question, can you share more information or resources about AutoGen? I am not seeing anything on Google.
I think it might be a typo. I probably would have meant AutoGen. I don't know how that came in,
AutoGen.
but
Okay.
yeah, I guess it's a typo in the slides. But yeah, it's I meant AutoGen. That is the framework by Microsoft. So yeah.
Perfect. So that was a typo. And with that, Chaitanya, thank you. Thank you so much for your time, your insights, and your awesome session. And here we are coming to an end of this day.